Hello and welcome to the Reigate College Further Maths video on using the scalar product to find the angle between a line and a plane, and also to find the angle between two planes. Now, with these questions, it's important you try to draw a sketch, even though some of you find drawing in 3 dimensions difficult. It gives you an idea of what's going on. So if we start off by thinking about trying to find the angle between a line and a plane, if my pen is representing the line, and I want to find the angle, I'd be trying to find this angle here between my pen and the desk. That's what I'd be looking to find. Now, there's a couple of different approaches. You can find the scalar product of the direction vector of the line and the normal to the plane. The reason you do that is you've often been given the normal to the plane. And you find that angle. So then you're finding actually the angle between the line and the normal. So you need to take that angle away from 90 in order to find the required angle. You can also use this formula, which is similar to the dot product, or uses the dot product, but gives you sine. The advantage of this is there's a little bit less remembering what you've got to do in order to find the acute angle. So let's have a look at 2 examples and see the different approaches you can use. So we start off with this one here. We've got a line and then we've got the plane. The plane is a sort of flat table, if you like. And we're told the equation of the plane is x minus y plus 2z equals 7. Now what this is telling you is that the normal to this plane is 1 minus 1, 2. So that's important that you realise that this is giving you the normal to the plane. We've got a line r equals 2, 1, 1 plus t times 1, 2 minus 1. So this is the direction vector here. So if we find the angle between the direction vector and the normal, so if I draw another little sketch here, here's the normal, here's the line with its direction vector. Maybe the direction vector is going that way on this one, I think. Then that's going to give us this angle here. But we're going to want to find that in the angle, so we want to find the angle between the line and the plane. So if we work through this, we find the dot product of the direction vector and the normal, and that gives me 1 minus 2 minus 2, which is equal to minus 3. We then find the modulus of each vector. So we've got root 6, cos theta is minus 3. So this gives me cos theta is 120 degrees. So the angle, this is the angle, remember, between the normal and the line. And that means that the angle we're looking for, so if this is 120 here, then this angle is 60. But we actually want this angle here. We want the acute angle between the line and the plane. So that's going to be line and the plane is 30 degrees. If you find that difficult to think about where the angles are going to be, then you can use the formula, and we'll look at that in the next example that we've got here. So in the next example, it says find the angle between this line and this plane here. So what we're focusing on, we'll do it first of all using the formula. So using the formula, we're going to say that the sine of the angle that we want is equal to, we're going to do b dot n. So remember that b is the direction vector of the line and n is the normal of the plane. So we're going to have 3 minus 6, 2. Write it as a big bracket so you can see what's going on. Dot 1, 2, 3, all divided by the modulus of each of these. So what's the modulus of this? That's going to be 36, 40, 49, square rooted is 7. Let's write root 49 just to help. Multiplied by, the modulus of this is 9, 10, root 14. And we'll then work that out. So we get here that this top bit is 3 minus 12 is minus 9, plus 6 is minus 3. So we're going to have mod of minus 3 over root 49 root 14. So we'll need to work out inverse sine of 3 over 7 root 14. And that gives me 6.58 degrees. If we wanted to do this using the dot product, we could find the angle between the normal and the direction vector. And if we work that out, we can then find the angle between the line and the plane. So there's two methods to use there, and you can see which one you prefer. If we want to find the angle between two planes, what we do then is we think of finding the angle between the two normals of the plane, and we don't have to do any rearranging for that, which makes it quite a lot easier. So if you think about this, I'll attempt a 3D diagram here. So if I've got one plane here, pages of a book, and here's another plane here. So it's like a book opening here. If I find this angle between the two planes here, if I imagine drawing the normals there, and this normal sticking out of that one, the angle between those two normals will be the same as the angle between the two planes. So if I look at these two equations here, I've got this one has a normal of 3 minus 5 minus 4, because the equation is 3x minus 5y minus 4z equals 8. The normal for this one is 3 naught minus 4. So if I find the dot product of the two normals, that's going to give me 9 plus 16 is 25. So the dot product of the two normals is equal to the modulus of this vector here, which is root 50, the modulus of this vector here, which is root 25, times the cos of theta, and that gives you theta is equal to 45 degrees. So we simply find the angle between the two normals. You can use the rearranged formula that says cos theta is, do the dot product of the two normals, the modulus of the two normals on the bottom, and find the modulus of all of this. And that finding the modulus of it all avoids the issue when you have an angle greater than 90 degrees. So look at the second example here. Find the acute angle between that plane and that plane there. Now in this question, you've got to identify the two normals. So the first plane has a normal that is 4, 3, minus 1. The second plane has a normal of 1, minus 6, 3. And if we work out this dot product, that's going to be equal to the square root of 4 plus 9 plus 1, multiplied by the square root of 1 plus 36 plus 9, multiplied by cos of theta. So what I get from this is that minus 11, because this is 4, minus 18 is minus 14. Oh, where's my calculation gone wrong then? Minus 18, minus 14. Minus 17, that should be, is equal to square root of 14, the square root of 46, cos theta. So cos theta is going to be, so we're going to need to use a calculator here. work out so this, we get that cos theta is minus 0.66989. And that gives me theta is 132 degrees. But we're asked for the acute angle, so we will take that away from 180, and that will give me that theta is equal to 48 degrees. If I did this using the formula, I could say that cos theta is the modulus of, find the dot product of the normals. So that's going to be 4 minus 14 minus 17 divided by root 40 root 46. But I want the modulus of the whole of that. So that's going to be 0.66989. And when I do inverse cos of that, I get that the angle that I want is 48 degrees. I shouldn't have written here theta equals and theta equals. I should have said, called this angle something different, alpha. So the angle, the acute angle between the planes. One way of remembering which of these formulas to use is if you are finding the angle between two planes or two lines, you're going to use cos. But if it's a line and a plane, previous example, then you use sine. So you need to try to visualize it as much as you can and then use the dot product to help you find the angle you're looking for.